So hello everyone. Today we are going to solve the problems power of 2, power of 3 and power of 4 and two more problems. So these problems are same. You can do this. If you can do this one, then you can also do this one and these two. These are easy problems. So power of 2 means if a number is given to you and if that number is power of 2, then you have to return true, and if and so on. So how do we have to solve this problem? A number, when do we say a number is power of 2? Let's take these examples to understand easily. Suppose n equal to 5. Suppose n equal to 5. So this is an odd number, right? This is an odd number. Odd number means this cannot be divisible by 2. Odd number, this is an odd number, so this cannot be power of 1. So this cannot be power of 2. Cannot be power of 2. Cannot be power of 2. This number cannot be power of 2 as it is an odd number, right? Now let's come to this one, 16. Is 16 can be power of 2? Yes, it is an even number, 16, and it can be power of 2. Now every even number cannot be power of 2. Like in this example, you can see that 10 cannot be power of 2. Here 16 is power of 2. 2 to the power 4 equal to 16, but 10 2 to the power you cannot calculate 2 to the power something equal to 10, right? So uh, how do you solve this? For odd numbers it is false, you have to return false. But if the number is even, how do you solve this? Let's see. If n equal to 16, suppose n equal to 16, then if you divide n by 2, n by 2, it is equal to 8, right? This is also even, this is also divisible by 2. Then in the next step, again divide this by 8, again divide this by 2, sorry. Next again divide this by 2, n divided by 2, which is equal to will be 4, right? And this is again divisible by 4. Now let's again divide it by 2. We will go on, we will carry on dividing by 2 until it becomes 1, right? So if we again divide it by 2, so this will become 2, that is n divided by 2 will equal to 2. This is also divisible by 2. Now let's again divide it by 2, so this will be equal to if we again divide it by 2, this will be equal to 1. So you stop here, right? You can see if it becomes 1, then return true. And in the process, no numbers were odd. Every numbers were what? Every numbers were even numbers. Now let's see for this number. Let's divide it by 2. So n by 2, what will become? N by 2 will be equal to 5. So you can see this is an odd number, so this cannot be power of 2, right? If we this cannot be power of 2. So here 16 was power of 2, we know that. So when we divide it by 2 continuously, it became 1 without any odd numbers between. But here it become an odd number by dividing 2, so it cannot be equal to power of 2. So let's code this approach. This will be very easy. Okay, power of 2, right? Where is the power of 2? Power of 2, power of 4, power of 2. This is the power of 2. Okay, now let's code this one. Suppose n equal to 0. Wait, there are two edge cases. Suppose if n equal to 1, then you have to return true, right? Return true, because 2 to the power 0 equal to 1, so 1 is power of 2. Now next, if suppose n is 0 or n n modulo 2 is not equal to 0, right? That is, if suppose n is 0, so 2 to the power anything cannot be equal to 0, because 2 to the power anything is greater than equal to 1, so this cannot be equal to 0. And if the number is not divisible by 2, that is if the number is odd, that is the number, if the number is 5, so you have to return false. So that cannot be equal to power of 2. In the example I showed you, 5 cannot be power of 2, because that was an odd number. So here also, if the number is not divisible by 2, that is the number, if the number is odd, then it cannot be power of 2. So return false from here. Now let's come to the main logic. So while my n is greater than 1, right? While my n is greater than 1, keep on checking that if my n modulo 2, if my n modulo 2 not equal to 0, right? If the in the process, by dividing the number by 2, if it becomes odd, if it becomes odd, then return false, and update the number n is equal to n divided by 2, right? If the number becomes odd, then return false. If it does not become odd in the process, then in the end, when it becomes n equal to 1, so this loop will be terminated, and you have to return true from here. Return true. Okay, so let's run this. Okay, so this. Okay, this is compiled successfully, completed the example test cases. Now let's try to submit this. This should be able to pass all the test. Yes, it is passed. Problem solved successfully. Now let's come to the power of 3 problem. It is similar to the power of 2 problem. Suppose if a number, let me write this, power of 2, right? Suppose n equal to which is not divisible by 3, suppose 1/4. And I will take another example, n equal to suppose 9 and divisible by 3, and another number which is divisible by 3, that is 15. So here n equal to 4. So if the number is not divisible by 3, so then return false, right? Then immediately return false, just like the previous one. If the number is 9, that is if the number is divisible by 3, then check, then again divide it by 3, right? Divide it by 3. Previously we were dividing by 2, now divide by 3, so it becomes 3. Now again divided by 3, now again divided by 3, so the number becomes 1. So it becomes 1. Here in the process, the 3, no number we are getting that is not divisible by 3, right? So that's why return true from here. Return true. Return true from here. That's why return true from here. Return true from here. Now come to this one. So if n equal to 15 divided by 3, if we divide it by 3, so this will become your 5. So 5 is not divisible by 3, so return false. So return false from here. Return false from here, right? Just like the previous one. Let's code this. This will be going to very easy. So power of 2 is done. Next power of 3. What is power of 3? Yes, this one. Okay. Similarly, if n equal to 1, then immediately return what? True, because k to the power 0 equal to 1. Next, if n equal to 0 or n n modulo 3. N modulo 3 is not equal to 0. That is, the number is not divisible by 3. Then return false from here. Right. Next, now let's come to the main logic. While n greater than 1, if in the process dividing it by 3, the number becomes not divisible by 3, that is n modulo 3 not equal to 0. If it is not divisible by 3, then immediately return false and divide it by 3 and divide it by 3. In the previous one we are dividing it by 2. Now here it is dividing by 3. Then in the end, if the number becomes 1 without creating any number which is not divisible by 3 in the process, then return true. Return true. Okay, so let's run this. This should be able to pass all the example test cases. So compilation error. Okay, this is capital N. Let's make it small n. Now let's run. It should pass again. Return true. String. Okay, it is saying string. Okay, let's see what is the problem saying. Given a positive integer, write a function to find if it is power of 3 or not. Yes, output should be yes. Return yes and no. Okay, I have to return. True means yes, a string. Yes. False means no. Okay, no. Right, no. Okay. False means no. No. Then true means yes. Yes. Now let's compile this. Now this should work. Okay. Now let's submit this. This should be able to pass all the test cases. Okay. Okay, passed. Now let's come to the next problem, which is power of what was it? Power of 4, I think. Okay, so we have done this. We have done this one. Let's come to power of 3. So power of 4. So what is the power of 4 problem? Here it is. So similarly we will do this power of 4. If given a number, okay, here I have written 1 or 0, right? So similarly, if my n equals 1, so I will return 1 from here, that is true. If my n equal 0 or n equal if n is not divisible by 4, that is n modulo 4 not equal to 0, then return 0 from here. Now let's check if while n greater than 1, if in the process n becomes not divisible by 4, then return 0, that is false, and update and keep dividing the number. N will be equal to n by 4, and at the end return true, that is 1. Okay, simple. Let's run this. This should be compiled. Yeah, let's submit this. This should be able to pass all the test cases. Okay, great. This is passed. So we have solved this too. Let me mark here. Okay, so I have solved this and 2 more problems, which is the general form of these problems, right? If do this, let's think this. Given two positive integer x and y, check if y is a power of x or not. Y is a power of x or not. If y is power of x or not, right? So what do we have to do? Previously we are checking if the given number is power of 2 or not, right? Here the given number is, let me write here, the given number. What is the given number? x and y. Check if y is a power of x, that is given number is y. And what is the power? Power is equal to, previously power was 2, 3, 4, here the power is x, right? If the given number y is power of x or not. So we will do what? If my x, if given number, that is y, if given number y equal 1, right, then return 1, then return 1. Next, if the given number y equal 0, or the given number y modulo x is not equal to 0, that is not divisible by x, then return then return false, so it is 0. Next, come to the main logic. While my y is greater than 1, if in the process y becomes not divisible by x, then return false from here and update y. Y will be equal to y divided by x. Y will be equal to y divided by x, right? Here x will be, previously we are doing 2, here 2, and instead of 2 it is x, and at the end the return true, that is 1. So let's run this. This should run. Okay, great. Let's submit this. It should be passed all the test cases. Okay, runtime video program took more time than expected. Okay. Y could be 10 to the power 8. So what should we do? I have to optimize this code. So how can we optimize this code? Any power of 1 is not equal to 8. How do we optimize this code? The given number is power of, if the given number is power of 1, okay, so if the given number is power of x or not, I have to check. So how can we check if how do you optimize this code here? How do you optimize this? When x was large, right, x was my power. When y is large, y could be 10 to the power 8 and x could be 10 to the power 3. If x could be equal to 1, right? So here x could be equal to 1, output 0. Okay, so if x becomes 1, I have to check here. If x becomes 1, then return false from here. But because anything power of 1 cannot be equal to any number, right? Now let's try to submit this, see what happens. Okay, passed, great. So this is how you can solve this problem.